Renewable energy sources, such as offshore wind, can reduce our reliance on the burning of fossil fuels and help to combat climate change. However, the blade tips of offshore wind turbines can spin at more than 200 miles per hour and stand more than 200 metres above the sea surface. This poses a potential risk to seabirds. 2/3 of the world's northern gannet population breeds around the coasts of the UK and Ireland, where they embark on long foraging trips from their nests. Each year, my team and I travel to the Bass Rock, off the coast of southeast Scotland near Edinburgh, where we study the impact of wind turbines on northern gannets. About 150,000 gannets breed at the Bass Rock each summer, making it the world's largest colony of this species. To help us understand the impact of turbines, we consider two questions. First, will the foraging locations of gannets bring them into contact with offshore wind farms? And second, does the height at which birds fly mean they are at risk of colliding with the turbine blades and being killed? We use two main tools to help us answer these questions: a GPS data logger and a pressure logger. This is a GPS data logger. This precisely records where the birds travel at sea. And this is a pressure logger. As pressure is lower at higher altitudes, this device can calculate how high the birds fly. A bird's location is recorded every 2 minutes, while the bird is at sea, and pressure every second. The tags weigh very little compared to the animal. Gannets weigh about 3 kilograms, while the tags have a combined weight of less than 50 grams. This is less than 1/10 of the weight of food that it routinely carries back to the nest. When we have caught a gannet, we weigh it to check it's in good condition. Then we attach the GPS and pressure loggers to its tail. We also attach a numbered plastic ring to the bird's leg so we can identify it later. We then release it back to the nest. After a couple of weeks, we recapture the bird to retrieve the loggers and download the data. We leave the leg ring on so we can identify the bird in future years and monitor annual survival of birds at the colony. Our data have shown that there is a risk of birds colliding with turbines. However, the risk can be greatly reduced by increasing the minimum height between the rotating blades and the sea surface. We're now looking more closely at how the movements and behaviour of birds are affected by weather conditions at sea and how this could affect collision risk. You will now hear more about how the renewable energy industry is working with scientists to minimise the environmental impacts of wind power.
My name is Jesper Køge Larsen. I am a biologist working at Vattenfall, leading a small team of experts supporting the business in assessing and mitigating impacts of wind farms on nature conservation interests, such as seabirds and marine mammals in the case of offshore wind farms. There are still many things we need to better understand about the impacts of wind farms on nature conservation interests. We need more research, and we have the ambition to play an active part in making that happen.
I'm Andy Gouldson, and I'm a Professor of Environmental Policy here at the University of Leeds. I work on climate change and I work around the world delivering low-carbon development. So fossil fuels can be massively unsustainable because burning them releases greenhouse gases, and that leads to climate change, which is a major threat to all sorts of aspects of life on Earth. The Paris Agreement was a breakthrough global agreement between multiple countries who all pledged to make significant cuts in their carbon emissions. And delivering on those pledges means probably investing heavily in renewable energy. Offshore wind is a major example of that, and here in the UK we've been a real world leader in investing and delivering offshore wind power in the last few years.
It is crucial to impact assessments and decision making on offshore wind farms that this can build on a solid knowledge base. On the effects, like what's the collision risk and the extent of disturbance, and not least on what's the consequences of such effects for the affected populations, which is the ultimate conservation question.